Everybody, welcome back to another fun and exciting pre-calculus class. And today's lesson will be in 4.2, that's rectangular and polar coordinate conversions. Basically, going from polar to rectangular and then going from rectangular back to polar. It's not extremely complicated, but it does take, you have to know the formula and you have to be able to work it kind of back and forth there. So let's go ahead and jump down into your book. That's on page 277. Page 277, rectangular and polar coordinate conversion. So here we go. The polar and rectangular coordinates of point P are shown in this figure. Okay, so here's the figure. The relationship is p squared equals x squared plus y squared. That should look familiar. That's the Pythagorean theorem. So this is your r squared or your c squared, and this is your a squared and b squared. And then it is also the tangent of theta equals y over x, cosine theta equals x over the rho prime, and the sine of theta equals y over rho are apparent from the triangle. So if you look through this, you should see those. Those should make some sense to you. I won't take the time to go through them all. From these equations, you can get this right here, and then this right here, that the theta equals tangent -1 or the inverse tangent of y over x. Notice this is your formula. They're just kind of telling you how they went through and got the formula. These also are the formulas from going polar to rectangular. It's just a conversion. So if you look through that, if you take the time to think through what I just read and look through this, it should all make sense why this works. But what's important right now is that you know it works and that you can work these formulas. So let's go ahead and let's try it. Let's just jump into it and let's convert -4, -2 to polar coordinates. So over here I have the formulas written down again so that we can get to them quickly. And then we'll go ahead and do that -4, -2 to polar coordinates. Well, what are we going to do? We're going to plug it into the correct formula. All right, so what are we doing? We're going from, these are rectangular, -4, -2. We're going to polar. So we're going from rectangular to polar. So we're going to use both of these. This is going to give us our rho, which is the first term. That's kind of like the x coordinate. And then the theta is our second one, which is kind of like the y. So you see right here, they kind of correspond. The rho corresponds with the x, and the theta corresponds with the y. All right, so we're going to use this one first. Let's go ahead and write it down and then plug into it. So rho equals the plus minus, and technically you don't need the plus minus. You'll see why in just a second. X squared plus y squared. So let's go ahead and just plug into it. So that would equal the plus minus square root of x is -4 squared plus y is -2 squared. Now those pluses and minuses shouldn't mean a lot to you right now because they're going to go away in just a second. So we're going to get plus minus, and this is going to be 16 plus 4. So it's going to be plus minus the square root of 20. We'll go ahead and break that down, and you get 4 and 5. The 2 comes out, so we have a plus minus 2 square root of 5. And so that would be our p coordinate. So I'll write it up here. So we'll have plus minus the 2 square root of 5. Now let's talk about that for a second, because we don't need both of them. If you'll look back in your book, it says there the positive answer is preferred. So we want the positive. You could do the negative, but then it gets really complicated, and it's just better to write these using the positive. So let's go ahead and go back over there, and let's write only the positive. So we're just going to get rid of both of these right now. So this is just going to be our p side, our rho side. And now we need to find our theta side. So what's going to go into the theta side is we're going to go back up here and we're going to get our theta formula. So we're going to use this right here. Theta equals tangent -1 inverse tangent of y over x. So let's write that down here. Theta equals tangent -1 of y over x. And now we'll just go ahead and plug into that. And so our y is -2, tangent -1 of -2 over -4. Negative, negative, that's going to be positive. So we can actually get rid of those because that turns it into positive. And you could, reduce that if you want. So it doesn't matter. We're going to plug it into the calculator anyways. So it'll take either one of those. So let's go ahead and pull out the calculator. So we're going to hit Shift Tangent. And then we're going to hit 1/2, or we could hit 0.5. It'll just be a little bit easier if we do that simple math. And we get 26.56. That rounds up. We'll round it up to 1 decimal place, so 26.6. So that equals 26.6. All right, so now you might say, okay, we're done. That just equals that. Well, kind of. All right. Now, one thing that I didn't tell you at the beginning, and maybe I should have at the beginning, we need to pay attention right here because tangent is actually positive in 2 different quadrants. All students take calculus. Don't forget about this. This is your friend. So in both 1 and 3, tangent is positive. So that's a problem right here because we don't know if we're in the first or third quadrant. So let's go ahead and sketch it out right here. So let's sketch out what we originally had. What was our original? -4, -2. So we'll just come over here, -4, 1, 2, 3, 4, -2, 1, 2. So we're going to be down here. So immediately when we sketch it out, we know that we are in the third quadrant. Now, that is important because this number right here is not in the third quadrant. How do we put it in the third quadrant? We put this into the third quadrant by adding it to 180. So 180 plus our 26.6 is going to give us 6, 6, 0, 1, and 2. 206.6 puts it into the correct quadrant because, again, it was in the third quadrant. Our original number, this right here, is in the third quadrant. So 206.6. 206.6. And then that would be the correct answer. Now, the second thing that it asks you is to convert 6 150 degrees to rectangular. So obviously, we're now in polar coordinates, and we need to go to rectangular. So let's go up here, and this is what we're going to use. We're going to use for the x, we're going to get rho cosine theta, and for the y, we're going to get rho sine theta. So x equals rho, it would just write it. Rho is 6 cosine theta. And for the y, we're going to get rho 6 sine theta. Now, if I was you, I would just plug this into my calculator right here, and that would make the whole thing a whole lot easier. 6 cosine, so 6 cosine, and then 150 equals, and it equals -3 square root of 3. -3 square root of 3. We could do that longhand. We could do that with our knowledge of the unit circle, with our knowledge of our triangles. But for me, calculator, much faster. So our x is going to equal that. Our y is going to equal the same thing, except for using sine instead of cosine. So let's go ahead and we'll do 6 sine of 150 equals 3. There we go, and so our y equals 3. And now we can just go ahead and write this. Our x is -3 square root of 3, and our y is 3. So again, not too bad there. Easy? No, but not too bad. Use your calculator, and that will help you out a lot right there. All right, next on page 278, here's what they want you to do now. They want you to convert this equation right here, okay, from a rectangular equation to a polar equation. We haven't done this yet, so how would we do that? So what we want to do is kind of use our formula that we had to kind of sub into this. If you notice, let me just rewrite this so we can see it. We have some pieces that we can put together. So let's go back up to our formulas here, and let's kind of look at these. If you'll notice right here that if we were to square both of these, what would we get? This would go away, and we would get rho squared equals x squared plus y squared. So let's go ahead and go back and look at that. We have x squared plus y squared right there. So what we can sub in is we can sub in, since rho equals that, this is basically rho squared. This equals rho squared. We have our 4x equals 0. Now if we go back up here, we know that x equals rho cosine of theta. So we could put that instead of the x. So plus 4 rho cosine theta. Now we'll use a little algebra here, and if I see I have a row here and a row here, I can go ahead and pull out my common row. So I'll end up with rho times rho plus 4 cosine theta equals 0. Okay, now I can break this down and say that rho equals 0 and rho plus 4 cosine of theta equals 0. If I move the cosine of theta over, I get rho equals negative 4 cosine theta. All right, so that tells me what my rho equals. Now, let's check this out. This is always going to happen. In every one of these, you're going to get rho equals 0. Rho equals 0 means that this is your pole. This is where you're starting off from, okay? This over here is what you're left with. This is your answer. So your pole is just kind of like, yeah, it's not really part of your answer. You're just saying like, okay, that's where this thing starts off at. And then over here, you just would write rho equals negative 4 cosine theta, and you're done. Last thing that we want to do in this lesson is we want to convert rho squared equals 5 sine 2 theta to an equation in rectangular form. Now we're subbing x and y in for rho and things like that. So we have rho squared equals 5 sine 2 theta. First thing I see is a rho squared up there from our formula. We'll go all the way back here. This rho squared basically equals what? It equals x squared plus y squared. So we'll go in here and we'll put in x squared plus y squared instead of the rho. And then that equals 5 sine 2 theta. Now we need to get rid of this somehow and change this into x and y. Kind of got to jump back into our toolbox of tricks here. We have to say that this is a double angle identity. You could go back to the front cover of your book, and let's look over there, and this is on the front cover of your book, page B, and it says right here with our double angle identities, if sine 2 theta, we have that, then that equals 2, bringing the 2 out front, sine theta cosine theta. That's important for us to use right here. So what we want to do is break this sine 2 theta, down into 5 times 2, we're bringing the 2 out front, sine theta cosine theta. And of course, we would still have the x squared plus the y squared out here. And now what we can do is just kind of clean this up a little bit. We can multiply that together, and that would give us 10. So x squared plus y squared equals 10 sine theta cosine theta. Now, these things we can kind of sub in from what we've done up here, and that is x equals this. Well, we're trying to get x, but if we divide both of these by rho, then that will give us our cosine, because that rho will cancel out, and so we get cosine of theta equals this right here. And if we do the same thing over here, then we get our sine of theta equals that right there. So let's plug in for cosine of theta, let's plug in x over rho. All right, so for cosine of theta, we were doing x over rho, and then for sine of theta, we were doing y over rho. and this is still times 10, and we'll put multiplication, and then this is still x squared plus y squared. Okay. You can do a couple different things here, I guess, but let's just go ahead and combine these. So we'll get x squared plus y squared equals 10 times xy over rho squared. Now maybe you're thinking, I hope you're thinking, I remember what rho squared is. Yes, I hope you do, okay, because we've done it several times. This is rho squared right here underneath of that sign right there. So x squared y squared is rho squared. So then we're going to do it basically one more time here. X squared plus y squared equals 10. And then we have x over y, and then we have over x squared plus y squared. We finally got it all into x's and y's. Lots of substitution going on there. Now you might say, I'm done. Well, not really, because we don't like this right here. We don't like that denominator, so we're going to multiply everything by x squared plus y squared. Okay, and that's going to cancel that out. And then I'm going to multiply it by this over here. So I'm multiplying by the same thing, so I can just hit a squared over there, and that's our answer. X squared plus y squared equals 10 xy. And that's about as simple as you can get that, and that would be your final answer right there. And maybe you're like, final answer, what's going on? You know, like I want to do more to it. All it was asking you to do is take it from rectangular to polar and from polar to rectangular. So once you get it as simplified as you can, there's nothing else you can do to it. It's just a lot of substitution and a lot of kind of algebra moving stuff around into its place. So yeah, that was exciting, right? You love it? Hopefully you like it. At least you like the first part where it was the points. I feel like that's kind of, straightforward. You just plug those into the formula and you get the points. The equations, a little bit more. We had to use some identities. We had to use some of our magic back from our toolbox that we've been using all the way through this course. But, in the end, it was just moving stuff around and substituting things in there. So hope you learned something there. If you missed anything, make sure to slide it back, watch it again. That's all I've got for you. We'll see you later. Have a good one. Bye-bye.